children, today again you are joining with Guru Gedara educational programs. Today you are going to learn science grade 7 lesson heat. So you are going to learn about heat and temperature. Temperature part that you learnt already. Hope you enjoyed and learned. Now today we are going to learn about heat, that is unit 14 in your lesson 14, second part of that lesson, that is heat. So first of all we see what is heat and temperature. That temperature you have already learned. Today we are going to learn about heat. Then you will learn that what is the difference between heat and temperature. So what is heat? Here there are two blocks you can see here. One is a hot block, the other one is a cold block. So this hot block, can you see the temperature is high? At the same time cold block temperature is less. So what will happen to this when there is a difference here? If there is a change here in this blocks, the heat of these blocks changes. So we can find out by learning heat. Look at this. We are going to keep this cold box on top of this hot block. What has happened now? Still the temperature, you know, hot block it is high, cold block it is less. When it is kept this way, what is going to happen to the temperature? We will see there this hot block has more heat, cold block has less heat. So you will see that heat will flow. How it will flow? Here from the cold block to the hot block. So now look at the temperature here. This is getting warmer. Cold block is getting warmer. Therefore, temperature rises up. Temperature rises up as a result of moving heat from the hot block to the cold block. So that is simply you need to understand, if it is heat, heat always moves from a cold place to a hot place. It happens. Now further you can see here, warmer one has become, this one also has become warmer. Why? Temperature has moved this way. Temperature has moved from the cold block to the hot, warm block to the hot, cold block. Then heat is always form of energy. It is a form of energy moving from one form to another form. It moves from one form to another form. How? From a cold place that it absorbs, cold place absorbs heat and hot place gives out heat. So that is what you saw here. Look at these two blocks here. One is a hot block, you can see it in red color, and this is a cold block, it is in blue color. So these are two iron blocks. What are we going to do? We are taking these two blocks in the two different temperature. So obviously you know hot block is a hot warm one, cold block has less temperature. So what we are going to do here, we are going to bring them together. What are we going to bring? This hot block is brought closer to the cold iron block. So we will see what will happen. There you saw that we brought that together. Then when it is brought together, we will see hot block transfers energy to cold block. Can you see? Hot block always transfers energy to the cold block. So when transferring energy, see what happened to the colors in these two blocks. Both became to the same temperature. Till they become the same warmer, same temperature, heat passes from hot place to the cold body. That is what you need to learn. Basically in heat, what is happening? Heat is a type of energy. It transfers always from hot block to the cold block. Thirdly, once they becomes the same temperature, when it reaches the same temperature, then transfer energy, transferring heat stops at that moment. Now here, when both bodies are at the same temperature, there is no any heat transferring. There is no any heat transferring there when they are at the same temperature. Now, we see what have we learned from here. Transfer of heat is flowing heat. What is transferring heat? It is flowing heat, moving from one place to another place. You know, always transferring food, transferring other goods, that means transferring means moving. It is moved from one place to another place. So, transferring of heat is moving heat from one place to another place. There is a question now. What is that question? How does it transfer? How does it transfer? It transfers from hot place to the cold place. Always energy is more in the hot object, hot place. Then energy is less in the cold place. Therefore, it transfers from the hot place to the cold place. So, it is clear, I guess. Now, what is about this heat and heat transferring? Basically, you have an idea. Here, method of transferring heat. Methods of transferring heat. So, there are things that which we can do things in different method. Example, if I tell you, if you are going on a journey, if you are traveling somewhere, you can travel from Colombo to Kandy by bus, by car, by on a train. You can find different modes. Same way, heat also can transfer in different ways. We see what are those. Basically, there are three. We are going to learn what these three are. Conduction. One is conduction. Secondly, convection. Radiation. Conduction, convection and radiation. So, remember children, there are three methods, three basic methods of transferring energy. What are those? Conduction, convection and radiation. So, we will discuss what these methods are. Some of you all must be familiar with these words. Anyway, we will learn in detail what are these methods of transferring heat. Right. Now, you can see this you see every day in your kitchen when your mother or grandmother, whoever who is cooking at home, you see this incident. It can be a fire hearth or your gas cooker. Fire is coming this way. You keep your saucepan on top of it, and sometimes you have to hold the pan as well to take it out. All these three methods you can observe there. Firstly, you see conduction. Here conduction. You can see that conduction, that holding hand, you're holding the pan handle. So, therefore, after some time, it will flow heat to your hand. It will flow heat to your hand. How it happens? Because of conduction. Because of conduction, you will feel heat here, right? Then convection. What is this convection? You can see water particles here, and you can see some black arrows there, some arrows moving up, some arrows moving down. Why it happens? That is how convection takes place. Surely we will learn about it in details. So, here that is the movement of particles. There are particles, it can be water or gases. Anyway, when it is moving only, you can find how convection takes place. Next, What is our third type? Radiation. Third method of transferring heat is radiation. What is this radiation? You can see, children, that when it is kept on fire, sometimes fire doesn't touch your pan or fire doesn't touch. Best example, sun. We get heat, but we don't touch it. Nobody is touching it, but still we get the warmth, we get the heat of sun. Radiation, that is the method which comes with radiation. So, radiation is without involvement of particles. You know very well, when light comes from the space, that there are in the space there is no particles, there is a vacuum, so still it can come through it, still it can come. That means when radiation happens, yeah, it happens through the medium particles, but even if it is not there, from one place to another place it moves. So, basic idea that you know, we are going to learn about these in detail. Right, we will see how this happens. Conduction of heat. This happens with a direct contact. You know very well what is direct contact, touching. If you hold one of your friend's hand, that is a direct contact. So, you can hold your table, just touch your table, that is a direct contact. So, here direct contact helps in conduction. How? This stove is there, heat there is given to the pot. Pot is made out of material, can be aluminium, can be clay, anything, any material. That material now absorb heat. That heat is passes to our water. So, stove, when it is contact, when it passes to the other, that is conduction. Right. Further, we will see what is this conduction of heat. Look at the definition. Method where vibrating particles transfer energy to neighboring particles. So, we will see some of these words must be not familiar to you all, but see, we will see what this is. Vibrating. You know very well, your phone is vibrating, right? When you put your phone onto vibration mode, it vibrates. Now, you know what is vibrating. Vibrating means around one fixed point, if particles move, that is vibration. So, here even if we do not see, vibration takes place. Method where vibrating particles, as a result of vibrating particles, energy is transferred. As a result of vibrating particles, energy is transferred to where? To the neighboring particles. Example, now you and your friend are seated there, you have a pencil, then you don't move, you yourself is not moving, but you pass something to your friend. You are not moving, your friend is not moving, but you are passing something to your friend. So, same as that, particles are not moving from place to place, but transferring something. What is that something? That is heat. So, this method of transfer of heat is called conduction of heat. So, first method, basic idea you know, particles should vibrate, energy should pass from one place to another place, then heat is transferring. Till what time? Till both material becomes the same temperature, reaches the same temperature. Where does this happen? We will see now. It happens in solids. You know very well solids. What are the solids? Particles in the solids are thoroughly packed. Example, when you take your table, chair, pencil, all are solids, right? So, they are all thoroughly packed together. So, solids help to transfer this type of heat transferring, but not all solids. We will learn what type of solid will help it. So, you can understand very well that solids, that there are no particles there which can move freely from one place to another place. They are thoroughly packed. Because of that only, that you can find out that easily this type of heat is transferring. Right. Look at this diagram. Okay. You can see there is a candle there lighting up, and a person is holding that, and look at the arrow. You know, when something is heated up, temperature moves from this corner to your hand, right? This corner at the flame corner to the hand. That is what the arrow shows. So, do you think that you can hold that forever? No, no way. Because your body temperature, you know, 36 degrees, around 36. So, once it reaches this temperature and after that more heat is given to you, you can't hold it. That is the very reason, children, you can't hold some hot things when you are trying to hold it at home or at school, heated thing, because you can't bear that up. But in this case, initially you can hold it, later on you can't hold this, right? So, we will see how this happens. As I told you that here, look at this, egg is in direct contact with the pan, and this pot of rice or what you are cooking, it has the direct contact without moving particles, it has absorbed heat. So, that is conduction. That is conduction, right. So, heat conductors. I told you all the solids do not pass heat. It is actually, we learned some like you may have learnt it already, heat conductors and heat insulators. Insulators, though we call it insulators, rather we can call it poor conductors, right. Poor conductors, they are most metals. There are metals, metals conduct heat well. So, most metal. The other thing, there are some non-metals as well, one non-metal actually, that is carbon. So, material which help to pass heat well, very well, are known as heat conductors. So, if materials allow pass heat from one place to another place, they are called conductors. We see some examples are given there. Some of the material you may be really familiar, it does not matter. We will see iron, iron you know very well, copper, aluminium, gold, silver. If you take these can pass heat very well. If your intention is to pass heat, then you have to use this material. Simply that. So, these materials allow heat to pass through. That is why we call it heat conductors. Then heat insulators. That's maybe a new word. Anyway, though we call it insulators, we can use another word, that is poor conductors. Poor means less ability, less abilities. Good conductors we can call insulators, poor conductors. Anyway, here substances which do not conduct heat. There are substances which cannot pass heat well, very well. So, they are known as heat insulators or poor conductors. What are those? Glass, wood, plastic, cloth, air. They cannot pass heat from one place to another place easily. So, if you want something, you may have seen that in a saucepan, or if you want to hold something, sometimes handles are made out of plastic. Sometimes you may have seen your mother or whoever who is cooking in the kitchen is using a piece of cloth or a glove to hold the pan. Why? There the cloth is an insulator. If there is an insulator, heat does not pass from one place to another place. So, it is called a poor conductor or insulator. So, these examples, if you know very well, glass, wood, plastic, cloth, air, hereafter you can find out if something, some material which is a conductor is covered with a insulator. What is the purpose? To prevent this heat passing from one place to another place. Right. I am sure now you have the idea what are conductors, what are insulators, and how conduction helps in passing their energy through this solid material. Right. Okay. We will come to this activity now. This is the activity you have to show how conduction happens there. Look at the diagram. You can see there is a candle there. Then you can see a metal rod. Now, do you know what is a metal rod? Is it a conductor or an insulator? Yes, it is a conductor. So, heat should pass through it. As I told you earlier, heat should move from this flame end to the other end. Therefore, we will see what will happen if you heat this. If you heat this end, what will happen to the candle wax which is fixed to this because it is getting melted. Candle wax is a material which is getting melted with heat. So, I will show you how to do this experiment briefly. Right. Shall we move to the method of doing this? Right. These are the material we need. You need an iron rod. This is an iron rod. You can see. Very easy. You can do this at home, children. There you can see I have already put some candle wax. So, melt some candle and you can put some candle wax. As soon as you put candle wax, what do you have to do? You have to take a pin and fix on it. So, there is another one which is already done for you all. I will show you the setup now. This is the setup. You can see very well. There is a rod here. You can see the pins which are fixed here. And now it is fixed with candle wax. Now, our next step. Now, we are going to see conduction. This is a conductor. We will see how this will work, how conduction happens when heat is given. Right. This is a spirit lamp. We light that up. Right. Now, what I am going to do is here, children, I am going to give heat. You can see this heat is there. I am going to give heat to this. Now, look at these pins which are fixed here, how it will fall down with the heat when I am giving to them. It will take little time for heat conduction, but see what happened to observe the pins. You know very well this conduction. Look at that, children. Look at that. Now, the first pin which is very closer to is it hanging down? Can you see? Yes. Okay, it dropped now. We will see. Now, that means heat has passed to the closest place first of all where the heat is given. We will see what happened next. Now, little by little that heat is passing through this conductor. This is a metal rod. So, heat particles, the heated energy only pass, but particles in this material do not move. You saw the second one dropping as well. So, if you keep furthermore, you will see others will also drop the same way as I showed you. So, I hope you understood this very well, right? So, that experiment you do in the laboratory to see how conduction happens, heat passes from the closest place to the end of that rod or the conductor. At the same time, you saw the first pin which is closer to the flame dropped first, then second one dropped next. So, you can understand if you have many, the last pin will drop last. Last pin in the sense which is away from the candle flame or the spirit lamp flame. So, why is that? Because that heat reaches the last end, because the last end only you can see that pin is dropping down. So, I am sure that it is very clear to you all. Look at this. This is the way that actually if you are setting up in your laboratory or at home you can do. You just need a small metal rod, little wax and some pins and a candle. Please do that and see. It is very much better if you can fix that to a clamp stand or anywhere a fixed point. So, what do you think here? Flame is there. What will drop down first? You think 1, 2, 3 or 4? Just think. Yes. First one will drop first because heat reaches first there from the candle. Fourth pin will drop last because heat reaches there at last. Hope you understood this practical. Why are we doing this practical? To show conduction. Conduction means moving energy through conductors or solids. Right. Observation. You know what is observation. What you see is observation. You can write. I don't have to give you observation even. Pins are dropping down. That is one. Pins are dropping down. Did they drop down at once? No. They drop down gradually. You know the word gradually. One by one. Starting from the heating end. Starting from the heating end, that is at the end, at the beginning of the flame. Heating end of the rod because of melting wax. Wax is melting. Why wax is melting? Because it is transferred to wax. So, you saw very well what happened there. Now, we will go to convection. We go to convection. You know already a first one. This is the second method of transferring heat. Second method of transferring heat, convection. Method of transferring heat through liquids and gases. There is a word for this, children. Liquid and gases. Liquids or gases are called fluid. You may have learnt it, or if you haven't, learn it now. Both liquids and gases we call its fluid. So, where does convection takes place then? Convection takes place through liquids or gases or through fluid. How? Through convectional current. It happens through convectional current. You may have heard about this word, convectional current in different places, especially when moving wind, convectional current. So, here earlier particles did not move. Now, particles has some involvement in this. We will see. Earlier now it reaches here. Look at this diagram. Pot has already taken heat. It has transferred to water. Now, water is a liquid. Water is a liquid. So, that liquid, how it is getting heated up? with the help of convection. How? We'll see how it happens. Look at this. This type you can't observe actually, children, but this is really what happened in liquid. You can see these arrows colors, at the same time some arrows here. Red color arrow, can you see it is moving there? Again it comes down. When heat is given, heat should be given, right. You don't have to have a same pathway, same direction. Look at the other arrow then. It is moving to this side and blue part it giving down. Red is hot particles. Red means hot particles. Hot particles when they are getting lesser denser. I know you are not much familiar with density, but density means that particles that getting lighter with the heat. This, when it is getting lighter, it moves up this way. It moves up this way and reaches. Now, upper particles are not hot as below one. They are cool. What happened now? They are coming down, right? Hot particles getting lighter and moving up. This is getting denser, then cooler particles comparing to this and moving down. Once they move down, they are also getting heated with the help of convection and it moves out. So, that is how, children, that happens throughout the liquid. There are some differences. You can't do this same way what you do at the sea level. If you are in Colombo, the way that you do, if you go to the top of a mountain, Mount Everest especially, you can't do this because pressure matters a lot for this. So, with the pressure, boiling point changes, but convection takes place everywhere at the same way, right. Every day your mother, or if you even want to have a cup of tea, you need to boil this. Same. The cooler molecules are coming down, warmer molecules are moving up, that is convection. So, in convectional current, what you need to remember here is heated particles. We learnt anyway heat moves from hotter place to the colder place. That you have to remember. So, here it has moved from the hotter place, red arrows, then to the blue part moving down means since they are cooler, they come down with more, it is not lighter as them. So, then they are getting heated up. This happens for a while and whole amount of liquid is getting heated up. That happens through convectional current. Right. Another way, another explanation. Briefly, I will explain this. You can see blue particles. What does that mean? All are in one temperature, cooler temperature. Here, when heat is given, what are the particles which are getting heated first are the lower particle. You know very well. The red particles you can see now, it is very, very hot now. What happens now when it is hot? That it becomes less denser. Once it becomes less denser, lighter, it is trying to move up. There you can see that the third diagram. It reaches furthermore, and when compared to these particles, other particles are now more denser, cooler particles. That means blue particles. Here they are coming down, and once they come down, they are also getting heated up. Can you see this? They are also getting heated up and they also move up. So, conventional current happens in the way of a cycle till the whole body or liquid or the fluid turns into the constant temperature throughout. Hope you can understand very well with this. Right. This is a conventional current of air. You can experience this in your day-to-day life. they are conventional current fire, right. So, of course, if you have a fire there, you can see if you keep something up or else what is getting burnt off, sometimes carbon particles, sometimes some other burning particles moving up. Very well, you can observe these children. You can do this again at home with the help of one of your elders or parents. You can have some fire under a tree, and there you can observe after having fire under a tree and the other plants as well, other trees rather. How? The tree which was there with the fire, when fire was there, you can see leaves are moving out. Leaves moving or shaking, we can say. But if you observe the other trees, leaves are still. You can do this practical experiment when there is no wind. It should be a calm environment. No wind will change it. Therefore, so what you observe is when fire coming out, leaves are shaking means what? Leaves are shaking means that this conventional current of air which moves up helps to move that. That is the very reason leaves in the other trees do not shake or move here and there. Due to conventional current, this happens. Right. Okay. There are two experiments. This is one in your laboratory. As I told you earlier, no need to do this to go to the school to do this. You can do at home even. See the material you need. You need some incense. Then you need a piece of cardboard, candle and a transparent glass. So, what happened here, we will see after doing the practical there. So, I will show you how to do this. Basically, you can try this out. Right. Let's move here to do this. Here you need a beaker. As I told you, you fix a candle there, then take a piece of cardboard or paper and keep it there, right. So, then you need to light up these incense. Before that, I will light up this candle. First, you light up this candle and put this cardboard there. There should be a space between. Hope you can see this. Hope you can see the setup. After that, children, you need to have some incense. You can have anything which is which can move out. So, now what happen when you keep this? Side here is hotter than the other side. So, don't allow it to getting heated the other side, then that will not work out, right. Then you have to have some smoke producing material. Best is this. Okay, we will see. When this is kept here, when that part is getting heated up, now it started moving. Just moving out, but observe very carefully what happened to the air which is moving down. Hope you can see that. Right. Okay. True enough, some are going up, but can you see gas is moving down and coming from the other side? Can you see? It is coming from the other side, not straight away which is going down. It goes down and coming from the other side. From the candle side, it is coming up. This goes down, it is coming out from the candle side. Very, very easy and very simple practical, right. So, I will explain what will happen to this now. Here, In this practical, you can see experiment. A side and B sides are there. A and B sides are there. A side, you can see it is cooler comparing to this side. It is cooler comparing to this side. So, you know this candle heats up this B side. What happens now? This side is cool, this side is hot. Now, cooler side, that particles are denser and it moves down. At the same time, this side, this gas is getting, gas in the beaker is getting heated up, it moves up. So, when it is just the gas, we can't see, children. That is what we use this incense smoke. When that smoke moves, the travelling pathway shows you the movement of air particles inside the beaker or atmosphere. This happens day-to-day life in the atmosphere, it happens, but we can't see that. When you use this smoke, the way that it is moving, you can find out the pathway. So, you saw it very well. It moves down to the cooler area and moves up there from the hotter area. So, this is called convectional current in air. Convectional current in air. Right. So, here that the experiment that we did and you understood how to do that. Conclusion. You saw the observation. Conclusion. When heated air rises from the chamber B, chamber B is this side. When it rises up, there, why? Because there is a lighted candle and it is getting heated, that air particles move up. That is the first conclusion. What is the first conclusion? When candle heated up the air particles on the B side, that it moves up to feel that the cooler air on side A is moving to that side. So, their heat travels through air as convectional current. Now, we will move to the other one. Right. This is your next experiment to see convectional current in liquids. Convectional current in liquid. Experiment to show convectional current in liquids. Now, we saw two things. First, we saw air, in air. This is in liquid. I told you, liquid and air is the fluid. Now, we will see how you are doing this. You need this type of round bottom flask. This is called round bottom flask. You need a spirit lamp or a Bunsen burner. Stand this way. And potassium permanganate, day-to-day life you call it Condis. You can buy it from any pharmacy. They are granules. You can take it and drop some candle wax onto it and cover it. Why? If not, it will burn up, it will diffuse in water. You won't be able to see this current. We will see whether we can do this experiment. First of all, I will show you the setup here. Here we will see the setup. Look at this. I have given you all the setup here, and the beaker and the candle wax is there at the bottom. It is covered, potassium permanganate or Condis is covered with this. Okay, I am giving heat with this. Now, observe it for a while. Observe this Condis or candle wax there are. Now, you can see very well. There the observation. Can you see heated liquid moving up? So, that purple color potassium permanganate or Condis is moving upwards. There when it is getting heated up and it is getting circulated down there when heat is given more and more. Okay. Then once it comes to the same color, the whole liquid, that it will be the same there. Right. Hope you saw it. Right. So, this is the experiment that you can do that. So, you understood what I showed you all. Hotter particles move up and cooler particles move down. They are getting heated up, again moving up. So, that is that experiment we do to show convectional current in liquids. Right. Here there is a small clip you can see. If you haven't seen that properly, you can see this, how the convectional current takes place when that part is getting heated. This is how the heated particles, water particles move out. Why we are using potassium permanganate here? To show that it is moving out. If not, we can't see water particles. Okay, hope it is very clear. So, what is our conclusion? What you learnt here is always that the colder particles, liquid particles moves down and hotter particles moves up or rising and sinking the colder particles. That is called convectional current in liquids. Convectional current in liquids. Right. Application of convectional current. You may have seen this very well. Right. Here, you know, if you are flying kites, you know this very well. If you are going to the beach, if you are closer to a beach area, if you have tried this up, you know where your kite moves. That it depends on the time. Where if you are flying the kite in the morning or in the evening rather, you will see different sides that it will move. Why? Due to convectional current. So, fishermen, that they use this convectional current in air to go for work. You know fishermen, usually your parents, that they go for work in the morning, but fishermen go for their work at night. Why they are going at night? Here the answer is there. Answer is always this convectional current. So, we will explain furthermore here. You can see this is the warmer air is coming towards this here, towards the land, warmer air moving out there during daytime. During daytime what happened? Sunlight there. Sunlight is heating this land up. When it is getting heated up, what happened? Land is hot, particles are getting warmer, it moves up. Always water particles move up, you know that. Then it moves up. At the same time, what is on top of sea, ocean is cool comparing to this. So, there is a gap forming here now. Why? Hotter particles went up, rises up. So, that fills that gap during daytime, and what happened there? It fills that gap and these particles move down. So, from the seaside to the land, that breeze comes. So, breeze comes from the seaside to the land during daytime. At night, same way, night it is cool because sunlight is not there, land is cooler comparing to sea, because sea which is got hot during daytime, cooling very, very slowly. So, here night it is hotter than this area. What happened? Particles move up at the top of the sea area and circulating this way, forming a gap here. Gap is filled by the air which is coming from the land side to the seaside. So, it moves, that current moves from the land side to the seaside is called land breeze. This is called sea breeze. With the land breeze, during night time only fishermen go for work. Now, you got an answer for that question. Okay. our last method of transferring energy, transferring heat energy, radiation. The method of heat transfer without the participation of particles. You know what are particles? Solid particles, liquid particles, air particles. There is no participation here. So, there is no participation of particles that it moves from place to place but with energy. So, there. This radiation every day you experience here. If you have a phone, that you experience it. As I told you earlier, from sun to the earth, light comes with radiation. Microwave ovens, if you have seen the waves, radiation only. Say if you want to get yourself warmer, here radiation. You don't go and keep your hands there. Even if you stay away from the place, the hot place, you get the heat, that is radiation. So, hope now you learned that what is radiation. This experiment shows how radiation is done. What you do is you take 3 cans. One is painted black, the other one is white, the other one is shiny metal. All are in the same temperature, filled with same amount of water, right? Then water in the tin can is heated by solar radiation. This is kept at sunlight, children. This is kept at sunlight. After some time, you will see different temperature in different thermometers. Can you see this? Painted black, painted white, shiny metal. So, temperature of water in black has risen higher than white and silver. Then temperature of water in the can with shiny outer surface has risen very less. So, you can understand that why it happened, children. Black always absorb light, heat energy. So, water boils up or heats up easily in black. Shiny or white material, heat reflects back. So, it will not help you to heat that material up. That is the very reason test matches, when we are playing cricket, they wear white to reflect light back. At the same time, people who are in this tropical area, that we mostly wear white uniform because it helps to reflect back, will not transfer heat to your body. That is the very reason. Hope you understood this experiment which is based on radiation. So, their radiation you can use this in your day-to-day life, right? Hot water in containers with polished and shiny. Hereafter you know you are going to use a black container to boil heat. Then sometimes if you are wearing colors, hot days, what type of things you have to wear? Lighter. Then it reflects back, right? So, because black always absorbs heat. Hope you understood very well about heat. We learnt about what is heat. Then we learnt how heat transfer. Then methods of transferring heat, that is convection, conduction and radiation. Then based on that, how we do experiments. You can do most of them at home even with simple experiment and show how those happens and how we are going to apply that knowledge, application knowledge of this heat transfer. That is all for today's lesson, children. Hope you learnt about heat and temperature. Join us with another lesson. Goodbye, children.